Hello, this is the ELP lab project on the topic phase shift oscillators. Myself, Harshdeep Shakya. I'm a student of Electrical Engineering branch of the 2021-2025 batch, and in this project, I will be discussing phase shift oscillators. Let's start with the definition. A phase shift oscillator can be defined as it is one kind of linear oscillator which is used to generate a sine wave output. RC phase shift oscillator circuit can be built with a resistor as well as a capacitor. The circuit offers the required phase shift with their feedback signal. They have outstanding frequency strength and can give us clean sine wave for an extensive range of loads. Preferably, an easy RC network can be expected to include an output which directs the input with 90 degree. Let's discuss the working principle. The circuit on the right shows a single resistive capacitive network which output voltage leads the input voltage by some angle less than 90 degrees. In a pure or ideal single pole RC network, it would produce a maximum phase shift of exactly 90 degree. And because of 180 degree of phase shift is required for oscillation, at least two single poles networks must be within an RC oscillator design. However, in reality, it is difficult to obtain exactly 90% of the phase shift for the RC stage. So we must therefore use some RC stages cascaded together to obtain the required value at the oscillation frequency. So by cascading together three such RC networks in series, we can produce a total phase shift in the circuit of 180 degree at the chosen frequency, and this forms the basis of our RC oscillator, otherwise known as the phase shift oscillator, as the phase angle is shifted by an amount through each stage of the circuit. Then the phase shift occurs in the phase difference between the individual RC stages. The phase shift is shown in the figure given on the right. Now let's discuss the full circuit. We know that in an amplifier circuit, either using a bipolar transistor or an inverting operational amplifier configuration, it will produce a phase shift of 180 degree between its output and input. If a three-stage RC phase shift network is connected as a feedback network between the output and input of an amplifier circuit, then the total phase shift is created to produce the required regenerative feedback is 3 times 60 degree plus 180 degree, that is 360 degree, and can be equivalently written as 0 degrees. By varying the resistances or capacitors used in the circuit, variable frequency can also be obtained. If the three resistors R are equal in value, that is R1 equals to R2 equals to R3, and the capacitors C in the phase shift network are also equal in value, that is C1 is equals to C2 equals to C3, then the frequency of the oscillation produced by the RC oscillator is simply given as is the formula given below, where Fr is the oscillator's output frequency in hertz, R is the feedback resistance in ohms, C is the feedback capacitance in farads, and N is the number of RC feedback stages. The complete circuit of the RC oscillator is shown on the right in the figure. Now let us discuss the pros and cons of RC phase oscillator. Pros: the oscillator circuit designing is very easy with basic components like resistors as well as capacitors. The circuit is not expensive and gives excellent frequency stability. These are mainly suitable for low frequencies. This circuit is simpler compared with a Wien bridge oscillator because it doesn't require the stabilization planning and negative feedback. Now let us look at some of the disadvantages. The output of the circuit is small because of the smaller feedback. It requires 12 volts battery for developing a suitably huge feedback voltage. It is hard for the circuit to create oscillation because of the small feedback. The frequency stability of the circuit is not good to compare with the Wien bridge oscillator. Now let us discuss some oscillations of oscillators in modern world devices. Voice synthesis, musical instrument, GPS units, generating signal for a wide frequency range, generating clocks in digital systems, and sweep circuits in TV sets and cathode ray oscilloscope. Thank you. That's it for my project.